Hey everyone, so in this video we're going to be discussing the chi-squared test, and it's really important in machine learning in terms of what is known as feature selection. So I'm going to read this article right here and basically pinpoint some of the important points that they made. Then we're going to do our own example with a data set that I found on Kaggle, and then we're just going to run through the code really simply and get to it. So right here he's just discussing some of the important things, degrees of freedom where you're subtracting the sample size minus 1. We've got the formula here, which I will run through here. I actually have it open here. So we're basically just summing up all the values in the rows of in the cells of the contingency table, the observed value, which is the value that is on the table, and then the expected value, which is what we would have expected to have gotten. And we're just squaring it and then dividing it by the expected again. So I like this highlight right here. In feature selection, we aim to select the features which are highly dependent on the response. What this means, of course, is that we will have more optimal models when we're creating our machine learning models. So the hypothesis obviously is that the null hypothesis and the alternative hypothesis. In a chi-squared, it's basically there's no correlation between the data for our null, with the alternative being that there is a correlation. We have a contingency table here, so obviously we're just going to be subtracting the number of rows minus the number of columns, or time. Number of rows minus 1 times number of columns minus 1. Very simple stuff to figure out the degrees of freedom. So we've got 1, 2, 2 minus 1, 1, 2, 2 minus 1 is 1. So that our degrees of freedom is 1. To find the expected value, we have to use a little bit of some probability. So basically, we need to find that what the probability of the person being male. So in this, we've got 216 over 400, which I'm assuming, yeah, probability of them being male, and then we want to find the probability of them exited gender. I'm not sure what this what exited means. Okay, so they're leaving the bank with values. Okay, sure. This is just their example. So obviously the probability of them being male and having exited both at the same time then, so we're going to do 38 over 400, which, or 80, sorry, exited, yes. So 82 over 400 times. So regardless, just simple math that we're doing. We've got the probability of alpha intersecting B. So that just means the probability of A and the probability of B at the same time. Okay, so that's that. So now we just plug all of that into here they're doing it in Excel, and we can go through that in a different video if we want, but today we're just doing it in Python. I like this. This is just the chi-square distribution at significance alpha, degrees of freedom 1, so the chi-square test statistic is 3.84. That is on the table, I'm assuming. We can look at the chi-square table again, just never mind. But so the value would be 3.84. We calculated it at 2.22, so that is left of the value. So we actually accept the null hypothesis. There is no correlation here. Yeah. So what is the significance of this? If the two variables are independent, though, we cannot use these variables when we're training the model. And I guess he's got some code here. Okay, I've got my own code, so we don't have to worry about his. Actually, I'll give him a like. Oh, NVM. Okay, so let's run through it in Python now. So let's get our data set. We're just going to go on kaggle.com. Wait for that to load. And I'm pretty sure this is the data set that I like. Zoo data. Yeah, so I have this already downloaded, so I might just, because jeez. Yeah, so I already have this downloaded, so yeah, this is the data set, and I like it because we have just some binary data, with just zeros, ones, binary. So let's download it and get it. All right. All right, everyone. So I got the data set downloaded. So we're just gonna start by importing our libraries just real quick. Obviously, we're gonna be using SciPy. Chi-squared, contingency. Okay, perfect. Then we're gonna get Seaborn because we want to make a nice graph. Just gonna make a nice graph with this data. Matplotlib. We're just importing matplotlib or pyplot, so that way we're able to just have it displayed. So we got our libraries. Let me just make sure I got a configuration set up here. Just real quick. Yeah, that's fine. Or actually, different configuration. Yeah. Sorry, guys. I figured it out. Yeah. I forgot to freaking put the document on it. Okay, real quick. Okay. Now, let's make the path to the data set that we have. So path, we're going to define our path variable. Users mod slash pi project slash kaggle slash tsv. So now we're going to define the zoo data just so we can read it in pandas real quick. I'm just going to show us real quick how it's going to look in pandas. And I might as well just print it real quick just so we can see what we got here. Okay. There we go. Okay, I got worried for a second. Okay. So we've got some data. We got the animal names. We got whether they have hair, feathers, whether they lay eggs, how many legs they have, their tails, if they're domesticated animals or not, and I'm not sure what cat size is, to be honest. So I'm going to do it really simple today. Let's look at what the correlation between animals that have feathers and eggs are. If there's any correlation between this, the fact that if an animal has feathers, if it lays eggs. So I just want to look at the data set real quick, and we can try and come up with a conclusion first, just to see what we can expect from the data. So we got animals with feathers, and there's a whole lot of other different defining characteristics. That's why I really like this data set. Aardvark doesn't have feathers, doesn't lay eggs. The bass doesn't have feathers, but it lays eggs. So I kind of want to know though, because there's a lot of this data. Does every animal with feathers lay eggs? Is feathers like kind of a defining characteristic for an animal laying eggs? So let's make our contingency table now. Really simple. Contingency table. I'm just going to call it contingency. And we're just going to make a pandas cross tab. Yeah, I call it zoo data. Okay. So we're going to take out the feathers column real quick, and then we're also going to take out in zoo data the eggs column, right? That's just what we want to look at. And why don't we just do this? Let's just print that. So this is going to count up everything. Remember what we were doing with your other contingency table here was that we were kind of counting up everything, looking at probabilities. So it's the same thing. what we're doing here is we have the data, the affirmative data, the basically observed data, and then we have our expected, what we would have expected to see. And it's just doing it for us already in Python. So let's read this data the right way. So feathers, none. We've got a count of 42. And eggs, none. We've got a count of no eggs, no feathers, 42. No feathers, but lays an egg is 39. Eggs, and no eggs and feathers is not there, but feathers and eggs. So I'm already making my own conclusions that okay, maybe they're probably correlated. But now let's look at the math that we're let's get some of our test statistics. Let's just prove it. Because the problem with this is a very simple example, but in real life sometimes the data might look very similar, but it might actually have a legitimate difference that needs to be accounted for. That there is a significant amount of difference, so that's why we're doing that. So we're just gonna get our p-value real quick. Let's see what it is. And let's just say it's at significant alpha. Okay, this is way less than 0, obviously. So I'm just going to say that our p-value is very close to 0, basically 0. So it's definitely a statistically significant result. So now why don't we just plot, make a really nice plot for us. Again, this is just a very simple tutorial. I can do another video on the math if we need to. But for now, I'm just gonna just rudimentary introduction to it, and it gives you the basic fundamentals you need to make your own analysis. I mean, I can definitely try it with different other variables too. So for example, is there a significant difference if the animal has feathers and if it's aquatic? Why don't we do feathers aquatic? And I'll show you we're not going to have actually we're going to have a very high p-value this time. How do you spell aquatic? Look at that, almost 1. So there's no real correlation that we wouldn't want to use this kind of, we wouldn't want to compare feathers and if the animal is aquatic, because of course there's like ducks and other animals like that, so that's not. But then if we do feathers and airborne, now we're going to have some really low p-value here. See? So that's basically how the chi-squared works. You're just seeing if there's a real important amount of difference between the two data points that we're looking at. And yeah, I was just checking if I was recording. Okay. So that's that. Why don't we now make our heat map? Because that's what I kind of wanted to do too, is just practice making like heat maps. Contingency. Let's just annotate it real quick. So this is just the colors that I want to use. Yellow, green, and blue is cool. Yeah, that's cool. And let's just plot it real quick. Okay. Look at that. So that's a really beautiful plot. I really like that. Yep. You can clearly see that there's some animals who have feathers are definitely airborne. And if they don't have feathers, they're probably not airborne. See, there's some there's some that are like neither. I'm actually curious what those are. That's why I wanted to do the feathers and eggs example, because it really is a good one for us. And of course, we have categorical data, right? So the categorical data, we have obviously two categories. Does it have feathers? Yes or no? And it does have eggs. If we had like the numbers, we'd probably want to use like ANOVA or something like that, which will probably definitely be the next video that I do, is ANOVA tables in Python. So that was a really simple introduction to a chi-square test, along with just, I mean, you can literally do this in 4 lines of Python code, maybe 6 if you obviously have to get the data, but really simple. It's the whole document's literally less than 20 lines of code. So that's why I really like it, and that's just really quickly how to do that, and it's really important for machine learning, and that's why it's an important statistical test to learn. And yeah, there we go. Have a good day.